Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to see that third problem with the simplex method. So simplex method, we are still looking for the variations possible or the special cases in the simplex method. So this is also a special case where this is where we have infinite number of solutions. Infinite number of solutions. Okay, so example 3.6. This is also a minimization problem. So minimize f, which is minus 40x1 minus 100x2, subjected to the constraints, inequality constraints, that is 10x1 plus 5x2 smaller than or equal to 2500, then 4x1 plus 10x2 smaller than or equal to 2000, and 2x1 plus 3x2 smaller than or equal to 9000. And also with the inequality constants, we're always given with these constraints that x1 greater or equal to 0 and x2 greater or equal to 0. So basically we have three constants and two variables. And next step is to formulate the standard form. So let's write side by side the standard form. Actually, it will be better to use the next page because of the fact that we have to form the table as well. So now standard form will be coming from minus f minus 40x1 minus 100x2. The slack variable, since we have three equations, m equal to 3, we'll be having three slack variables, that is 0 into s1 plus 0 into s2 plus 0 into s3 equal to 0. Then we have 10x1 plus 5x2 plus s1 plus 0 s2 plus 0 s3 equal to 0. Sorry, that will be 2500. Then you have 4x1 plus 10x2 plus 0s1 plus s2 plus 0s3 equal to 2000. Finally, 2x1 plus 3x2 plus 0s1 plus 0s2 plus s3 equal to 9000. So s1, s2, and s3 are the slack variables. Then let's form the first iteration. So table basic variables. Basic variables. Then we have, so our basic variables are basically S1, S2, S3, and F. Then we have our all variables. So all variables will be basically x1, x2, then s1, s2, and s3. as well as the right hand side values and the ratio, that is right hand side values with respect to the key column. So we already know all the terms, so that's why you're not explaining them here. So if you have any confusion, you can see the other videos related to this one. So now slack variables are easy. So it will be 1 0 0 0 1 0 0 0 1, and then the combination is 10 5 4 10. Then you'll have a 2 3 2 3. The right hand side values are 2500, 2900, and here you'll have minus 40, minus 100, and then all zeros. Also, one thing we have to keep in track here is this is minus f, so it's better to give here minus f. So what is our next thing? The step one is to choose the minimum, the most negative values column wise. So step one, most negative value, and this is the most negative value we have. So this is our column, key column. Okay, so once we have the key column, we have to select the ratio. So basically 2500 by 5, that is 500. And then 2000 divided by 10, that is 200. And 900 divided by 3, that is 300. So now we can see step 2 is basically finding the minimum positive ratio. So minimum positive. Step 1 was actually minimum negative, most negative. So based on that, this is the value that we have to choose. So this is our key row. Bottom line is we need the intersection, because the rest of the calculation will be based on the intersection. And also you know that the key element, that is 10 here, we cannot keep this magnitude, rather we have to make this magnitude to be 1. So let's make it 1. So we have to divide all the parameter here by 10. So now if you divide all the parameter here with 10, then what you're going to get is here 4 by 10. 4 by 10. This will be 1. This will be 0. This will be 1 by 10, 0, and then it will be 200 here. Okay, so based on these, we have to form the next table, as well as we have to use the pivot mechanism to eliminate rest of the value. That means we have to make this 1 0, this 1 0, as well as this 1 0. So let's try to form the next table based on this one. So, and also if you are interested, if it is helpful, then we can consider this one to be row 1, row 2, row 3, row 4. It's not necessary, but if you use it, then it will be easier to form the next tables and to apply the pivot operation. So here, the next table, again, the basic variables we'll have, we'll start basic variables, then all other variables. It is x1, x2, s1, s2, and s3. Finally, right-hand side value and your right-hand side, the ratio that is right-hand side with respect to the key column. So now S1, now our which element entered and which element exit, we have to see that, identify that well, that one as well. So let me just complete the table first, then we'll go to the next step. Okay, so S1. Now to see which one is entering and which one is leaving, let's go to the next. So as you can see, X2 will enter and our S2 will leave. Okay, and also then you have 4 by 10, 1, 0, 1 by 10, 0, 200. So this should be the case. So instead of S2, we have to write X2. Then you have S3 and F minus F as well. So this is 4 by 10, 4 by 10, 1, 0, 1 by 10, 0, and 200. So how can we make the first one 0? So how can we make the first one 0? So basically to make the first one 0, that is R1 prime 0, previously we have the magnitude. Just check what was the magnitude in the last case. So as you can see, 5 is there. So it has to be R1 minus 5 R2. Okay. To make it 0. So R1 minus 5 R2. So prime as well. So this will be 0 definitely. So these are values are 0. Now, if you apply those things, then you're going to get 1 here. I'm just writing quickly because the method is already explained in the previous examples. So minus 1 by half, then 0, 1, 5, whole 0. Similarly, to make this one 0, we have to give R3 prime equal to R3 minus 3R2. Then this one will be 0. And the other portion will be here, 8 by 10, then 0. Then you will have minus 3 by 10. Then you will have 1 and 300. And finally, for the last one, what you're going to get is minus, that will be R4 prime has to be equal to R4 plus 100 times R1 prime. So that will give a 0. Okay, so this is previously, if you check the x1 value, okay, so this one 0, this one 0. Then we have this is also 0, and this will be 10, 0, and 20,000. Okay, so what we know so far is we have to have a most negative value. in column wise the f values, but somehow as you can see that none of them here is negative, so that is an indication that our we have reached the solution. Also, at the same time, as you can see, all the cost coefficients. Oh, one thing that you have to remember that somehow if you write f equal to c1 x1 plus c2 x2 up to cn xn, if n number of variables and n number, so these c1, c2 up to cn, these are also known as cost coefficients. Okay, so as you can see that definitely we reached our optimum value of f, there is no doubt. But at the same time, all the cost coefficients are actually zero. So basically these two are zero. So this is the indication that the problem have multiple solutions, basically infinite number of solutions. So condition, let me use a different color. Condition is all ci double prime is greater or equal to zero, which and the present solution that gives the present solution is optimum. Okay, and optimum values can be given like as x2 equal to 200, and x1 value is not available, so we can say that x1 value will be 0, and the minimum value f minimum will be minus 20,000. Actually, minus f equal to 20,000. So from that, this is what we are going to get. Now, the criteria that actually gives you the infinite number of solutions, the cost coefficients correspond to the non-basic variable is also 0. So these are basic variables. Now x2 has become a basic variable, but non-basic variable is x1, which you couldn't turn inside the basic variables by entering and leaving another coefficient, one of the slack variables. So if the non-basic variable becomes 0, in this case xi equal to 0, this is an indication that we may have alternative solution may be there. So alternative solutions may be there. Okay, so as you can see here, so neither the values are plus or minus. If they are minus, we cannot stop. So optimal is not attained. So this is one thing. And if all the values are 0 here, especially the non-basic one, that is an indication that our solution may have multiple alternative solutions. To be honest, infinite number of them may be there. So to find out the infinite number of them, we already have one solution. So we actually have to have at least 2 points or 2 solutions. So this is maybe x1 star, x2 star. Then we should have another set of x1 star and x2 star. So that will give us eventually the way to figure out the rest of the solution. So to do that, what we have to do is we have to figure out, we have somehow the non-basic variable, we have to enter this thing into a basic variable, and when we enter this thing into basic variable, another solution will be available, and then we can have, from the 2 points, we can have infinite number of solutions. So x1 it will definitely enter, but we have 2 choices, either x1 can exit or f2 can exit. So as book has taken the example of S1, I'm also following that one, but you are you're requested to experiment with the S3 as well. So if X1 is leaving, so this should be your key column. And based on the key column, we have to find out the ratio, that is 1500 by 8. And this will be your, okay, so 200 divided by, okay, one thing also important here is, one thing is, even though I'm trying to calculate the values, but these values are not necessary, because we already have decided which will which parameter will enter and which parameter will leave. So based on that, actually we can choose the key row as well. So even though we're trying to calculate or figuring out the values, but those are not actually necessary. So once we do that, the next target is to figure out the values of x1. So x1 has to be 1, so it has to be divided by 8. So it will be 1, no doubt about it. Then you'll have 0. Then you'll have 1 by 8. 1 by 8. And this will be minus 1 by 16. Minus 1 by 16. This will be 0. And this will be 1500 by 8. As well as these values, by using the pivot, we have to make these 0. Okay, so let's figure out the next table, even though not necessary for optimal value. Optimal value is already or attained, but we have multiple solutions to show that one and to find out any suitable value along those multiple solutions. We have to find out the second point. That's why we're going for the third iteration. So again, basic variables, then all variables, x1, x2, s1, s2, s3, right-hand side values. Ratio is not necessary, but just since we don't want to forget the formula, just keeping it there. So now it will be x1, s1 left and x1 entered, x2, then s3, and then we have finally our minus f. Yeah. So here, this will be 1, this will be 0, 1 by 8, minus 1 by 16, then you'll have 0 and 1500 by 8. And using the pivot method, so this is your row 1 double prime, so row 2 double prime. We know that we have to make these values 0. So row 2 double prime will be row 2 minus row 1 double prime multiplied with 4 by 10. So if you do that, this will be definitely 0, and the rest of the value will be 1 minus 1 by 20, 1 by 8, then we'll have 0 and 125. Similarly, R3 double prime will be R3 minus R3 prime minus R1 double prime into 8 by 10. So this will give us 0, 0, minus 1 by 10, minus 1 by 4, 1 and 150. And the last one will be It is already 0, so no operation needs to be done. So 0, 0, 0, 10, 0, and this is 20,000. So our optimum value is this one and this one. So x1 is 1500 divided by 8, and x2 is 125. And optimum value is f minimum is minus 20,000. So since we have 2 points, the first set of points are basically, say, x1, capital X1 set is 0 and 200, and capital X2 is 1500 by 8 and 125. So we have 2 points. So our optimum, any other optimum points, x star can be lambda x1 plus 1 minus lambda by x2. It should be capital, so x2. Where your lambda values range from 0 to 1. So if we just do a bit of calculation, then x1 star x1 star and x2 star will be having values like this. So equal to, so lambda into 0, so basically 0, lambda into 0 plus 1 minus lambda 1500 by 8. Then you have lambda into 200 plus 1 minus lambda into 125. Simplification will give us 1 minus lambda into 1500 by 8 and 125 plus 75 lambda. So now, since we already have mentioned that lambda value will be ranging from 0 to 1. Okay, so you can experiment with different values. Say arbitrarily take lambda equal to 0.5, plug in the value, figure out the x1 and x2 values, and plug into the function the minus 40x1 minus 100x2. So you're going to see that for any value in between 0 and 1, whatever the value you choose, you're always going to get f minimum equal to minus 20,000. So this is a special case with infinite number of solutions. At least you need 2 points, and from these 2 points, using this formula, lambda x1 plus 1 minus lambda x2, you can easily find out the infinite number of solutions in between. So this was the third special case of the simplex method. Assalamu alaikum wa rahmatullahi wa barakatuh.